Okay, let's see what we can do with three subsets in the Venn diagram. Here's an example, and with three subsets there creates 8 parts. And as we previously mentioned, 1, 2, 3 are probably the easiest parts with slight variations. Area 1 still represent all the elements in A only, and area 3 still represents all the elements in B only. And these elements are just in B, they're not in A, they're not in C. And same thing can be said about region 1. They're only in A, they're not in B, they're not in C. So, but let's look at area 2. When I talk about area 2 is slightly different from the previous example with just two subsets. This light blue color shaded area, that's area 2. And you notice that area 2 is only, oops, sorry about that. Does it erase? There we go. Area 2 is all the elements in A and intersect B, but they're not in C at all. Okay, so none of the elements in C so far is in 1 or 2 or 3. Now let's take another look. Let's jump to 5. 5 is really interesting. 5 is the little bitty corner there, and that's that green part. Let's see, there, right there. So I'll do 5 this way. So 5, you notice, is the only part that's all the elements has to be in A as well as in B as well as in C. So A intersect B intersects C. So it's the intersection where all A, B, C meets. So if there's any elements in A that's only in A but not in B, not in C, doesn't meet the criteria. Or an element in both A and B, like in those area 2, but not in C, that does not meet in the criteria, doesn't belong to 5. Okay? So region 4 represents the elements in set A and C, but not in B. That's probably easier to see now. So 4, let's go back to 4. It's A and C intersect, but it's none of the B's business. And the opposite is true. Area 6 is everything in set B and C, but not in A. So it's where B and C intersect, but not in A. And area 7 represents the elements in C only, but not in A, not in B. That's our C only. And area 8 is the area for all the elements in the universal set U, but not in A, not in B, not in C. So those are not A, B, or C. None of them. Okay? So if you want to do write it in a more mathematical way, you can say it's the complement of A union B union C. Remember, union is adding everything together, is addition. So if I add A and B and C together, and then they take their complements, meaning what's not A and B and C, that's my region 8. So for any Venn diagram with 3 subsets, I want you to list these 8 areas out, and then you'll have a good idea of where each sets belong to, and when they ask you questions, you can manipulate them more easily. So let's look at some examples. Okay, so here's an example. It says draw a Venn diagram to illustrate the set A intersect B, intersect C complement. So first notice that we've got three subsets here, A, B, C. So immediately you should have the Venn diagram in this corner here, A, B, C, like the one we just drew, 2-9, figure 2-9. So that's what you should draw out when you have A, B, C, three subsets. Okay, so step 1 is completed already. Now let's look at step 2. The second step is to list out all of these 8 areas. And so the easiest way to do it is if you have a highlighter or a marker and look at it this way. So if I have, I can start with the universal, let me change the color. I can start with the universal set. Universal set is easy. It's area 1, 2, 3, all the way to area 8. And set A is the peachy one. The peachy one has, if you look under the peachy color, you have elements in area 1, 2, 4, 4, and 5, right? And with the same method, you should see that area B has 2, 3, 5, I think it's 6. And then finally, set C has all the elements in 4 on top, 5 across, and 6, and finally area 7. And that way we got all 8 areas covered. So that's your step 2. Okay, because we have already completed step 2, I'm just gonna continue with step 3. So this slide is a little off, I apologize. So now that we listed out everything, we know exactly where each region is, and we can begin to put the problems together. Notice that we're asked to find A intersect the complements of B intersect C. So the thing to do is, before we reach the final conclusion, we need to first find, give me a highlighter right there. We first need to find B intersect C. And then we need to find B intersect C complement. And then we layer set A over that to find all the intersection for A intersect B, the complement of B intersect C. So let's first proceed with the first step. B intersect C. Oops, I always forget to switch back. B intersect C. B intersect C, as you can tell, where B and C, two circles intersect. Now give me the highlighter, right? Where they intersect is these two regions. I have region 5 and region 6. Okay? Everything in 5 and 6 are both in B and in C, and that's what intersection means. And therefore, B intersection C complements is everybody else that's not in this area, which is 1, 2, 3, 4. Then we skip 5 and 6 because they are in B and C intersection. And then it's 7 and 8. Okay, now we finish the second step. The third step is to find A intersect that complement of B intersect C. So now let's put A right underneath here. A is area 1, area 2, area 4, and area 5. Now let me change the color of my pen. You notice that between these two, where they have in common, in other words, where they intersect, I think are 1, 2, I have no 3, I have 4, do I have 5, 1, 2, I think that's it. And now let's compare that with this visually. Notice that B intersect C complement, it's everywhere that's white in this diagram, including everything in here that's white part. And where A overlaps with the white part is area 1, 2, and 4. And therefore, I can easily verify my final answer. Oops, I'm sorry. Made a mistake there. It's not A. My final answer for A intersect complement of B intersect C is area 1, area 2, and area 4. That's how we solve that problem, that example there. Okay, it's quite a bit of work, I know that, but that's how you solve it. And once you solve it, you make sure that you shade that area. So let me find a nice color for us. A little bit, let's see how this works out. So 1 is here, oops, 1 is here, 2 is here, and 4 is here. So let's, hopefully it doesn't bleed over. So it's all that pastel color right there. I'm doing this blue color there. That's what we're talking about. It's not perfect, but you got the idea. You got the idea. It's that circle of A minus 5. Did I? 1, 2, 4. Yep, circle of A minus that little 5 there. You have to carve out this little piece there that doesn't belong to that intersection. Okay, so I hope this is helpful, and make sure you complete your example. Okay, once you finish your own examples and you know that you can illustrate a set statement involving 3 sets with diagrams, make sure you check on the box here. Also, on a separate sheet of paper, if you recall the project we started with your own ethnicity and race or races in your family or in you, think of an example, but only pick 3 races or 3 ethnicities. Whatever you pick, it's fine. Give me an example and draw a Venn diagram on a separate sheet of paper. If you need markers and highlighters, let me know. I will provide them. That's one of your graded assignments for this unit. Okay, thank you guys.